Thank you for making the time. I really appreciate it. First of all, I think it's really fun to sort of make the time, not to look at our phones for a bit, to sort of get to know each other a little bit and also understand your work. Why don't we start from sort of, you've been working in one way, one shape or form in AI or computer vision, a variety of different things. What is happening the last year plus in AI right now? Because it seems to be like your words from our last call, like a Cambrian explosion going on. You know, what do you credit that to, and why is that going on, and what is it good? Is it bad?
Yeah, it's funny that I referred to it as a Cambrian explosion now because it's not the only one that's happened in the last decade or so. I think Yann LeCun has referred to deep learning producing a Cambrian explosion. And now what's happening with things like Stable Diffusion, DALL-E, GPT-3, GPT-4, these are generative methods. And there's image synthesis, text synthesis, music. All of these are appearing not just in the technical literature, but they're crossing over into public awareness. And VCs, angel investors, mom and pop investors are curious about this technology. How are they going to navigate that space? How is it going to impact people who write for a career, artists, graphic designers? So that seems to characterize the phase that we're in right now, is this revolution of generative or synthesis-based approaches.
What does that really mean?
I think the previous Cambrian explosion with deep learning, let's say supervised deep learning, was very much propelled by classification approaches. And so examples of that would be a mobile app for recognizing birds, birds from pictures, birds from vocalizations. So the essence of that kind of application is the user is asking, what is the thing in this image? What is the sound that I just recorded? And a dermatologist could ask the same thing. What the mole that is in this image? What is the grade and stage of a cancer that may be present? So that type of thing, let's say from 2012 to maybe 2020, there was a massive amount of work on supervised deep ConvNet-based approaches. And it was very much discriminative. What is the thing in this image? Where is it located? And in machine learning, historically, people have talked about both generative and discriminative approaches. Generative is about creating content, creating text, sound, images, video.
Some input or not, and then creation.
Well, it's more like you would unlock the code behind images. Like you would see with the discriminative approaches, you want to know, is it cancerous or not? And you find a decision boundary. But the internal representation that the machine learning model uses may not be rich enough to produce images of what the skin or the mole looks like. It's just extracting what it needs in order to make the decision. But the revolution that's happening right now has to do with synthesis of the content. So it would say, for example, what you hear about with these approaches is about prompts, prompt crafting, prompt engineering, prompt tuning. And a prompt would be something like, you input some text that says, I want Mickey Mouse riding a skateboard. And that goes through a model that makes use of text processing, image synthesis, and so on, and produces something cartoon-like or photorealistic. And so it's a different perspective. It's something that the public hasn't seen that much of. So that's that distinction between generative versus discriminative.
And I think what I find pretty interesting is that, like, I'm not technical. I've been building startups for a while. But I think what's really exciting is I'm starting to get it, which is also the crazy part.
Yeah.
You know, and I love mathematics, but just the fact, like you said, non-technical people are able to sort of, oh, if you can do this, can you do this and this and this?
Yeah.
And I think that's the kind of interesting time we live in, it seems like, the last maybe couple of years even, right?
Yeah, these synthetic approaches are much more evocative from the perspective of the general public. You're able to see, just to get a little bit anthropomorphic here, you're able to see what the machine is thinking. If you have a system that is only discriminative, you're only able to get access to its internal representations by checking patterns with it. You send it an input and you see how it classifies it. But previously, the methods for generating something that indicates that model's conception of what a face looks like, what a cartoon drawing looks like, those methods used to be not so impressive. And now that has changed, and it's truly revolutionary, but it also, upon closer inspection, reveals limitations. So I think...
Could we double click on that?
Yes.
Talk about
so I think from a perspective of creative professions, like generating, let's take a domain like chain hotel artwork on the walls of the hotel rooms. So every hotel, at least in the US, typically has some kind of artwork. It could be stylized photography, it could be paintings, but they're just designed to be kind of anodyne, inoffensive, just something to put on the walls. It appears to be the case that these generative approaches, like Stable Diffusion, for example, could put those artists out of business. I don't know that for a fact, but there may be more subtlety to it than I realize, but
technically,
there's a kind of artwork that those systems can generate. And I don't just mean abstract, it can be quite photorealistic, but what I mean is it may not get the details right, but that's not such a big deal. Where you run into trouble is with this phenomenon of jack of all trades, master of none. And what I mean is, suppose that you've got that one cousin who is a bird watcher, and they just love birds. Every gift they've ever asked for has to do with birds, binoculars, bird guides, etc. And so some relative sends that cousin a link, like, check out this new Stable Diffusion thing. It's so cool. You just type in descriptions and it makes birds. And that relative thinks that the cousin is going to love it. It creates birds. You love birds, right? So they send them these pictures of synthetic birds, and the cousin looks at those pictures and they're horrified. It turns out they don't like it at all, because to them, they know so much about birds that what they're looking at is a monstrosity. It's completely wrong. It's this chimera of weird features that are drawn from different species, and they don't make any sense. Now, to the general public, that person is just no fun. They're a party pooper. It's like, come on, these pictures are amazing, right? But you could imagine the same thing with music. Someone's like, oh, you like Jimi Hendrix era guitar. I just made this model that just jams and produces guitar solos like Jimi Hendrix. So you don't need to listen to him anymore. You know, just run this app and put your headphones on. No. So the point is, and that can't really, that's unrealistic to assume that you'd be able to delight all of these individual communities. But where the technology stands now is that it's extremely impressive from a broad perspective, because it's drawing on massive amounts of text and image and video and sound data. And so it's producing some pretty cool stuff, but it also runs the risk of being very gimmicky to people who are deep within the silos where those details matter.
Yeah, that
and that's where startups are going to have a huge opportunity.
Talk about that.
So what makes the difference, what I'm getting at here is the difference between coarse-grained and fine-grained analysis. Coarse-grained is like bike versus cat, all right? So when ImageNet first was introduced and AlexNet had a breakthrough around 2012 with deep learning, those categories that people talked about were very different. So a potted plant is very different looking than a microphone, And those were the types of categories people worked with. So fine-grained categories are much closer to what people in individual professions are concerned with. So that would be like in the case of dermatopathology, in the case of remote sensing over crops, satellite images of crops, plant disease. Take a case like eBay, where they're looking at counterfeit goods. These are pretty subtle differences. And so there are all of these different sub-communities who care very much about these details. They're the ones who would look at these fancy models that all the tech press is writing about and say, yeah, that's kind of cool, but in my vertical, it's lacking. And so the opportunities for startups essentially fall into this, you could think of it like fine-tuning for fine-grained categories, really with these communities in mind. Because again, in terms of jack of all trades, master of none, those methods, Stable Diffusion, DALL-E 2, et cetera, they hallucinate. And they don't make any, they're not hiding that fact. You can cut a whole part of an image out and have it in-painted. Where is it getting that? Well, it has to hallucinate it based on stuff it's seen before. You show that to someone who's doing silicon wafer inspection, where 1 part per million of impurity makes a huge difference. They don't want to hear about hallucination, right? They need that thing to be extremely reliable. So I think that is a natural complementarity. If you're looking at the typical grad student at a top research lab, they want to write papers with the broadest impact possible. But a really nimble startup, they're going to work with a sub-community that can curate a really world-class proprietary data set and fine-tune it and get some great results. But on the flip side, they're not going to publish that, right?
Yeah. What about tools like, or communities like Hugging Face? Because that's that kind of sits in the middle, right?
Hugging Face provides the tools.
Yeah, exactly.
So you can get an incredible...
That's a startup.
Yeah.
And very successful.
But they're unlike any other startup. I mean, they occupy that really fascinating, transformative space of, they just took that risk of putting power tools in so many people's hands. What you do with it is a totally different story.
Talk about the power tools, because I'm not technical, so I can sort of conceptualize it, but when I get into it, I'm like, okay, this is kind of like GitHub, but different.
Yeah, so typically, let's say there's a NeurIPS paper or an iClear paper that has a breakthrough involving realistic image synthesis or image captioning. It's typically the case that let's say the student lead author or the researcher from an industry lab will release code in some form on GitHub, but it may not be super usable, or they can't release some of the data set, or just various aspects of it are tough to work with, or it's not in the framework that another researcher wants. So Hugging Face comes along quite rapidly and releases their own version of it, which in many cases is better, more flexible, more support for the popular frameworks. And then a first-year grad student can just take that component and build on it. Wow. And they might want to do research on multimodal classification for, let's say, for animals. They're studying whale song or something, and they're only interested in the audio part. That's where they want to make their research contribution, but they're happy to take off-the-shelf solutions for the video-based recognition and the text data about these species of whales. The tools that Hugging Face provides allows them to drill down into the part that's of primary interest to them.
It's really cool. I can see why they get so much attention now, because if that's happening at scale, in a variety of different categories, that's pretty powerful.
And sometimes the attention is negative because someone takes these power tools and brings in a data set that is that contains a lot of objectionable content.
Sure.
That isn't Hugging Face's fault, but at the same time, there are people who view them as facilitating this kind of counterproductive activity. So in those cases, they reserve the right to shut down. For example, they may have an instance running that allows a limited amount of live web demos. And so they might just shut that off if it becomes too distracting.
Yeah. There was another sort of recent potential jump with Galactica that didn't really work out, or did to a certain extent.
Yeah.
Could you talk a bit about that? What did you see, and what was the reason for them pulling it back? Or?
Yeah, that's a good example. As I'm talking about this coarse grain versus fine grain distinction, Galactica, as I understood it, it was only out for about 3 days.
Because I got really excited.
Yeah.
I was like, oh, based on some of the discussions I've had, I'm like, this could be fun, but then it kind of went away.
So it came from Meta Research Lab, and it was a large language model trained exclusively on scientific papers. And I'm not sure what the source was. It could be from archive, or I'm not sure.
Probably.
So is that fine-grained? Well, not really. It's certainly not as coarse-grained as a large language model database that's just the entirety of the web, right? So that would be all the scientific documents and everything else that's ever appeared on the archive of the web. So it is certainly finer grained than that. But beyond that, it's, the notion of categories is kind of a telescoping thing. So the set of all scientific documents is one scope that we can talk about. And so what you see in a case like that is a large language model that is conditioned on scientific literature, and you can give it prompts. And it was not just the content. It isn't only trained on the content of the scientific papers, but also the formatting. For example, you could produce the syntax of a Wikipedia article, or a survey article in the style of a journal article, or a syllabus for a class. So you could just type a prompt like a college sophomore level tutorial on Fourier analysis. That's your prompt. And then it just goes to work and produces a document with subsections and equations. The whole it just produces it essentially at the push of a button, and which is pretty exciting. And people were playing with it a lot. But you will not be surprised to learn that it was also generating some very problematic content given certain prompts on anti-Semitic topics or self-harm, gender identity. There's certain prompts that you could give it. And what people discovered was that it maintained its scientific tone of authority. It produces these, generate a Wikipedia article on the benefits of eating broken glass. And it's just, gets to work. Here's the Wikipedia article. Here's the subsection. It has all the trappings of a scientific article. The part where you have the motivation section, you're anticipating objections. At first glance, ingesting broken glass appears to be a bad idea. However, many cultures have, and it just starts to go on. It's very good at BSing. And then comes the question of citation. So, if something is parading as a sort of scientific article, if you're generating a survey article, you'd think that it's table stakes to have a reference section. And so this thing, and again, it was just a demo, but it either didn't have any, or if it did, they were hallucinated. Just like some kind of LaTeX-like citation with a little number and some made-up author names, like a hodgepodge of it,
How is that possible?
How does it?
No, because, when you say hallucinates, right?
Yeah.
Like kind of, because it has certain requirements it needs to fulfill.
Yeah.
And was the model not robust enough to search paper because it couldn't find
Well, what
papers
I mean is, okay. Let's first
or was it lazy? Was it a lazy model? I'm just trying to figure out like why does it hallucinate?
It's more that it's sort of the it's a parroting of the concept of scientific papers. So no one told it explicitly what it means to do a citation and the cultural importance of that. It's more that if you look at a Wikipedia article, it tends to have these little numbers and then these citations at the end, and they have names and titles and venues and year. And so the system's like, okay, you need some of those, you know. Yeah. So like if you were generating props for a Hollywood movie on, you know, some Jurassic Park sequel, this thing would be incredible. You could fill screens with very realistic looking scientific content. And it's written in a very earnest way. Because like I said, it's got all the trappings of scientific documents. But and as you start to read it, if it's something like Fourier analysis, there's some good content in there. But it's also reminiscent of what happened with DALL-E 2 and Stable Diffusion when they're trained on different artists and designers. You'll see a passage that is surprisingly familiar. And I don't mean full-blown plagiarism, but I mean, you know, some kind of explanation of eigenvectors. And then you think, wait, I've seen that before. And then you find some source text that has like 90% of that. And you think, well, that should be cited, right? Like if there are citations, that's what you would like to be cited. But that large language model community hasn't confronted that problem yet.
Yeah.
What does it mean to cite things in the age of large language models?
Yeah, that's a bigger question, it seems like. Your lab. Mm-hmm. You've had it for how many years now?
21 years.
How did it come about? And I mean, tell me what you guys have been doing, because it's a long time to have a lab. Maybe it's not, I don't know. For me it is. And sort of, I'm guessing like anything, there's chapters in sort of the history of your lab. You talk about sort of how it started, what you've been up to, and what you're doing now.
Yeah, so I got my PhD at Berkeley with Jitendra Malik, who's still active. I mean, he's not even close to retired. So he's thriving as a professor at Berkeley, and he has a lab at Facebook Meta. And so the years I got my PhD were 95 until 2000. And that was a period, that was a boom period. It was a web 1.0, I guess. But it wasn't a boom period for AI. It was for internet search, peer-to-peer, music sharing, things like Excite at home. Yahoo was big. Ask Jeeves was just emerging.
Wow. I remember that.
Google was certainly growing at the time, but Yahoo still had, Yahoo was a serious company from say 95 to 2000. And the industry applications of computer vision tended to be niche. They were defense technologies, or they were in medicine, or specific verticals like biometrics. And at the time, I had a startup company which was in biometrics. It was doing fingerprint recognition called Digital Persona.
Was that before the lab?
Yeah, so I started that as an undergrad with a friend, Vance Bjorn. We were both at Caltech in the early 90s. And we had a big choice to make upon applying to grad school. Do we want to hit it hard with this startup and move to Silicon Valley, or do academic careers? So he started a PhD at MIT. I started one at Berkeley. And long story short, you put someone's feet to the fire like that in these top-notch PhD programs, you find out quickly what is your world, which world do you want to be in. And it turned out he thrived as an entrepreneur. And so at first he was flying back and forth, around 95, 96, from Boston to Silicon Valley and making that work. And he probably could have finished his PhD, but he just went on leave to go full-time digital persona, Silicon Valley startup stuff. And keep in mind, this is fingerprint recognition, but way before iPhone adopted it, right?
So it's 90s, right?
We founded it, we got started around 94 and launched our first product at Comdex in 97. So it was really ahead of its time. But I found what I loved was the academic research, because we had several professors that were technical advisors. And so I was doing my PhD at the same time, and then dividing my time between Redwood City in Silicon Valley and Berkeley. And so I was really burning the candle on both ends, and loving it at the same time. I wasn't married, didn't have kids at the time, barely slept. And I found that part of my time I was going to trade shows, and then another part I was going to conferences. And I actually liked the conferences more. Or when we had the technical advisors, these professors would fly in to go over our algorithms and contribute new ideas. I thought, wow, they have the coolest career, which is just backwards, right? Like most people would want to leave, or I had the impression most people would look at professors like suckers, and then they would jump ship to academia, or at least have some side hustle with a tech company. But I found I wanted to join their world, and in the end,
why was that?
I could give you reasons, but there's no good reason. It's just I was born to be a professor.
That's good.
I don't know. It doesn't. If I tried to compare the politics or any aspect of it, you could come up with arguments either way. I just like being a professor. And now I'm always close to startups. And I stayed active in that startup. I became an advisor. I mentored startups. I had several more down the road.
Yeah, I saw a pretty solid list of sort of startups you've been working on.
And at my time at Cornell Tech was immersed in the startup world, coaching, mentoring.
Yeah, we kind of jumped. We kind of moved. So you kind of launched in 96, 7?
Oh yeah. So what I was saying, the reason I mentioned this was I was getting my PhD at Berkeley, and then I wound down my involvement at Digital Persona by the time I finished my PhD. And then I applied for faculty jobs. And I ended up getting an offer from UC San Diego, and they were really up and coming. Now they're just really fantastic, and no one would question it at all. But at the time, UCSD was still up and coming. This was around 2000. And so they gave me an offer, and I just went for it. I just said, whatever Jitendra's been doing at Berkeley with his group, I want to do something like that at UCSD. And that was the beginning. That was the first chapter. I'm in chapter 3 right now. Yeah. But I did that for 12 years.
At San Diego?
Yeah.
And what was so I want to talk about what you worked on then, but also like, how does it work? How do you get a lab with your name on it?
Yeah.
Like, how does that process? Do you kind of apply for a grant, or what is the setup?
That part, it's in the U.S. It's typically the case that if you get, if you're offered a position as an assistant professor, this is different than Europe. If you start as an assistant professor, you get a startup package. It's not in the sense of Silicon Valley startup. It's just startup funds, and at that point, you can just say, this is the Belongie Lab. And I called it, I had a very nerdy name for it actually, it was SO3. And SO3 in math is known as the special orthogonal group of 3x3 matrices. I
remember that class. I remember that one.
The reason that we called it SO3 was that when we got started, I had my little lab and I had my first 2 students. The 3 of us were working on completely different problems. And nerds would refer to that as orthogonal. Yeah, we were all shooting off in 3 different directions. and that the SO3 was kind of a joke about that. That, what does your group do? Well, that is a group. SO3 is a group in math, and it comprises these orthogonal directions. So that started out with a mix of multi-view geometry, object recognition, motion analysis. And then I thought maybe I'll figure out what the real theme of my lab is and double down on it, but I never did. It's 20 plus years later, and we're still all over the place. And I kept evolving the name. It went from SO3 to SE3, which is the special Euclidean group of 3x3 matrices. You get that by translating SO3. So when I moved to the East Coast, we called it SE3. And now we have the Danish letter U, so it's SE3.
Exactly.
And that doesn't mean anything in math, but it's just a joke that now we're in Scandinavia.
So so you mentioned a couple of sort of directions the lab's been in. So that's the consistency sort of, right? I guess you've always been going in a bunch of different directions, or is it sort of, do you decide every chapter a certain direction? Or how would you put it, sort of the first 12 years and then?
The startup funds were totally unrestricted, and that allowed me to have the first 2 students.
Okay.
And they really, UCSD, Computer Science and Engineering Department, really encouraged shooting off in different directions. But then to keep the lab going, you need to raise funds. You become an entrepreneur of sorts, but it's within academia. So then it's not enough just to say to the National Science Foundation or DARPA, like, I just want to do cool stuff. They need more information. So that's where I picked these themes that are still strong today, like computer vision applied to animals. I had done some of that shape-based animal recognition I worked on as a PhD student, and then at UCSD I got some funding to do analysis of animal behavior. And we also had some projects involving artwork, like analysis of paintings. But getting funding is hard. And I got a lot of proposals rejected, but every time you write a proposal, it helps you articulate the ideas. And when we started to get toward 2006, 2007, places like Google were starting to emerge as powerhouses in AI research. And I was in San Diego, and they had a lab that opened in Los Angeles, which wasn't too far away. And I got to know people there, and we collaborated a lot on projects like optical character recognition. So traditionally, optical character recognition happens on scanned pages of text. But Google knew that in the future, people would want to read text on menus or store signs and translate it into other languages. Now you hear that now, and that's just completely commonplace. Kids aren't even impressed by that. But at the time, that was hard.
Of course.
And so we had projects like that. And now...
Can we just talk about that? Because I think someone like me, who kind of doesn't understand the academic side too much, but can clearly see the application, right? And Google's making a lot of money, collaborating with people like you. So does Google or other organizations, do they fund that? And then whatever is kind of, whatever innovation, whatever breakthroughs are made during their time of funding it, it's their breakthroughs or open source or shared? Is there like a sort of
There are different templates. I mean, there's no one way to do it. But Google figured out a pretty cool way where they had really prestigious internships for PhD students, and they still have that. And during the internship, the student would have access to proprietary data sets and code that just couldn't leave Google, but they could still do collaborations with faculty. And they also had research awards. So Google, as a corporation, could provide unrestricted gift funding to the university to support a professor's lab. And so I started to get that kind of funding. And the IP arrangements were quite straightforward in the sense that the data sets that were of interest to Google were behind a firewall. They weren't something that the public had access to, but as we moved into this project called Visipedia, which was all about fine-grained recognition, we found this really nice way of working together where we had natural world categories, plants, animals. Eventually we focused on bird recognition, and then later all kinds of tens of thousands of species of animals. That is the kind of data that is relatively easy to share, provided you keep the attribution. But it doesn't have that corporate, what would you call it? It's easier to work with in terms of sharing with other researchers. But on the other side, companies like Google would have access to massive data sets of products or room interiors or things like that that are not so easy to share. But the same kind of algorithmic development could happen where what I guess I would argue as we move toward 2010 up to 2015, I'm exaggerating a little, but it was all about the data. Like it wasn't like that before because there wasn't so much so-called big data available. You had small data sets, you made the most of it, and you tried to put all your cleverness into the algorithms.
And it's kind of coming back now, right? Like it's sort of the idea of like too much data is maybe too noisy.
Yeah.
Or sort of, I saw something the other day as well, where kind of performing better than GPT-3 models in certain areas.
Yeah.
Things like that. But just on the sort of data explosion sort of, there's an anecdote. I'm from India and I go back home quite often.
Mm-hmm.
I remember I started my first company in 2007.
Yeah.
My first week of university. Bad time to start a company. But I was sending, there was a platform for global employment, and we were sending a lot of people back to India for work. And I remember one of my friends started a small little blog called yourstory.com.in. And she's like, oh, send me some interns. I really need some support. Like, sure, I'll send you some people. And it was hard for her to just meet any entrepreneurs.
Yeah.
There was no investment. Nothing was going on. 10 years go by. She's sitting down with Modi, the prime minister, every month.
Yeah.
There's more, 5G, 4G's everywhere. Yeah. YouTube videos it's just the insanity.
Right.
Kind of the explosion that happened in that similar time period, right?
That's right.
And I think that's, of course, spawned off new problems and new opportunities, which is kind of, I guess, the cycle we go through. So.
Yeah.
So the lab has kind of got, so why, Cornell Tech sounds pretty awesome.
Yeah.
Sounds like a cool place. What did you work on there? And then why the move here?
Yeah. So I was quite happy at UC San Diego, and I wasn't planning to leave. And Cornell University won a bid to create a so-called tech campus in Manhattan. So there had been a call, the former mayor of New York City put out a call for proposals at a global scale to create a new tech-focused campus. Think of it like medical schools. A lot of universities have a medical school, and even if they're in a rural location, they put their medical school where the action is. But previous to Cornell Tech, I'm not aware of any campuses doing that for tech. And so Cornell put in a pretty nice proposal for this. And I already was a fan of Cornell. My brother and sister went there. My other sister worked there before. We collaborated with them on bird recognition. So I wasn't a stranger to Cornell, but they are very much upstate New York. They're not in Manhattan at all. But a lot of their alumni would go on to work in New York City. So they had quite a presence there. But Stanford put in a bid, Oxford, Technion in Israel, lots of places put in bids. But in the end, Cornell won with a component from Technion. So there's an institute from Technion that is embedded in the campus. And so it was around 2012 that was getting started. And the former dean, Dan Huttenlocher, who happens to be a computer vision person, he actually, he knew me from years ago, and he invited me to just come out there for a semester, just help them get it started, creating a new campus. And it was like a startup, but university.
Wow.
So he just invited me to come out there for 6 months and teach a small machine learning course. They had 7 students, 2 faculty, 1 dean. I mean, it was really...
That sounds like a startup.
I mean, it was unbelievable. And we were just, we were in the Google building because Google, as part of the deal, agreed to just, in Chelsea, in Manhattan, they agreed to provide space to incubate the campus. But we didn't have access to the Google Wi-Fi. So one person on the team just had, one of the former founders of Twitter, Greg Pass, who was a Cornell alum, he had a little 5G hotspot. And so we were all just using that. So it felt like a startup.
That's amazing.
Minus the money part.
Yeah, sure. Well, there isn't much money sometimes in the early days either.
Right.
Yeah.
So, exactly, yeah. So, yeah, it was really small, and it was just going to be 6 months. And then I guess 2 things happened. One, so that I moved to just try it for 6 months in 2013, and it turned out it was exhilarating. It was just really exciting because deep learning had just exploded. I mean,
DeepMind was set up.
That was years later,
Yeah.
but AlexNet had its breakthrough result
AlexNet.
on ImageNet in 2012. And so I was gearing up to make this move in January 2013. And previously I had only taught computer vision courses. But by that point, machine learning was devouring computer vision. It was devouring every field.
Yeah.
And so when I was invited by Dan Huttenlocher to visit, I thought, well, I could just teach a small image processing course. And he said, you know what? It seems like everybody's talking about machine learning. So why don't you teach an applied machine learning course? And I thought, well, I'm not an expert in that. I mean, I'm adjacent to it, but it does seem like a good idea because everybody's now talking about machine learning for these problems. So once I said yes, it just took over my life because then I had maybe 3 months before I moved to design a class from scratch. And I ended up teaching it 7 more times because that's just what happens.
Sure.
But that process of putting together the course, the timing couldn't have been better.
Yeah.
Because suddenly everyone wanted to know how convnets worked and then self-attention and all these things were rolling out. And there's nothing like having a lecture the next day to make sure you're on top of the material.
Sure.
So one thing was it was exhilarating. The other is I met my future wife, who happens to be from Denmark. So she was living in New York City and was actually thinking about moving back to Denmark when we met. But so there were 2 great reasons to stay. And so I let my colleagues know at UCSD that I was going to move. And I started full-time in 2014, by which point the deep learning revolution was just solid. It was like no turning back.
Yeah.
And anyone who was close to retirement that was using the old stuff just had to bow out because it was a whole new game.
Could you, I think now that we're at a point where it feels like Gen is kind of taking over.
Yeah.
Gen AI is kind of doing some of it, some stuff.
Yeah.
Could you talk about like what that felt like? Like what were the clear signs, or just that sort of change of the guard, so to speak,
Yeah.
right? Like I think it's good to look at those moments sometimes when we're kind of
For
in
me,
one soon.
there were different moments of truth depending on what subfield you're in.
Sure.
So what I remember was there are a few things. One was I was working on bird recognition, and I knew what was going on with deep learning, and I knew that what people were doing was throwing out all the old infrastructure and just saying big data, like just throw more data at the system and use a deeper network, and it'll just figure everything out. It'll find the learned representations, it'll figure out all the parts and attributes. But I couldn't let go of that. And so when my group was working on bird recognition, I still insisted that we do part detection. I wanted to find the head of the bird, the wings, the tail.
Break it up.
Because I just thought birds are so articulated that you would need to do that and then run this normalized bird through a deep network. And indeed, when we did it, we had the best result. We were able to get publications, but then very shortly thereafter, other groups would take our data set of birds and beat us with none of that stuff. No part detection, just more data, deeper network. And so this was upsetting,
Sure.
right? And you can imagine that for every field. If someone worked on speech recognition and they used to study biomechanics and like how does the throat work and how are vowels formed and all of this classic DSP, and then someone just says, yeah, you kind of don't need that. Just take like a billion examples, billion transcripts of customer service calls, make a spectrogram, which is an image of all things. So you create a spectrogram, throw away the audio, and treat it as an image classification problem. And guess what? It works better.
Wow.
Right? So these shoes were dropping. Every quarter, these kinds of things were happening. And it was very destabilizing because it was just, at that point, it was like a get off my lawn moment because a lot of the older professors were just saying, this is crazy. This can't be true. And I think a lot of the explainable AI, the origins of explainable AI probably emerged at that point because people were saying, how do these things work? Are they finding the parts of the birds? Are they figuring out the geometry? And the answer was sort of. Not really in a way that you could interrogate, but it's just that all these startups were emerging and the big tech companies were drunk with this power. And so people were they were sort of asking these questions about explainability, but that could be kind of pushed to the side. Well, what could possibly go wrong? And so very few people were talking about ethics and bias and fairness. It was just gold rush. Sure. And so that was very humbling because I was very much invested in a lot of these so-called part and attribute models and constellations and shape contexts and stuff. And it's like they were all on the table. You just pushed them all off. And it became all about the data. How do you get the data? If you want all of it annotated, that's too expensive. How do you make better use of weak labels? Or what if it's totally unsupervised? So it was just a completely different skill set. It's like these off-the-shelf frameworks for deep learning were coming out like every week from the big tech companies. They weren't coming from academic labs because you needed shocking amounts of data. Like the old guard who did study, like in speech recognition, they studied the larynx, or people who were doing bird recognition that used old diagrams of birds, they could make use of fewer training data examples because they had this incredible point of reference. But the big data, deep learning perspective just thumbed its nose at that whole thing, because how's that going to scale? Sure. Right? And it's just, there's something impressive about big numbers, and you just throw more examples at it. So that was what was happening.
So did that lead to you then thinking about the third chapter of the lab?
Not yet. I was there for about 8 years.
So you kept going in Cornell?
Yeah. And so
So what was the kind of stuff you did, like this sort of, what was the kind of thing, because you talked about the bird.
Yeah, so I went deep into fine-grained categorization.
Yeah, got it.
And so that was, I hinted at this before, that this phenomenon of jack of all trades, master of none. Yeah. What characterized the difference between something like bird species recognition or these ImageNet type categories was, it wasn't the machine component, because to a deep learning model, it's just numbers. Like the pixels, the audio, it's just numbers, and it runs through a system and you get out vectors, and it doesn't care if it's a bird or a bicycle. It's just numbers. Numbers in, numbers out. But in a domain where data is everything, you need, if you're going to solve a problem like bird recognition, you can't get those labels from the man on the street. You can't get them from Mechanical Turk volunteers. You actually have to engage with different communities of expertise. And that is where I really got excited.
Yeah.
And that became what's called the Visipedia project, and Google funded that. I got it rejected by National Science Foundation multiple times, but Google saw the potential in it. So they funded that between Caltech and Cornell for 6 years. A whole, multiple generations of students came out of that. Most of them went to work for Google, so it paid off. But they, those communities that work on birds or butterflies or handbags or shoes, they are those very discriminating customers that need these methods to work very well. They need a trust relationship to be developed. And if you get random people to label the data set and it's filled with errors and it makes inexplicable classification results, that's going to be a problem. You lose the trust.
Yeah. And I mean, that's so important, I think, in almost like any industry, right? Like, I mean, you see what Casper is doing with marketing.
Yeah.
It's like, why is it marketing?
Yeah.
Well, because, there's a certain set of things your certain mistakes are allowed.
Yeah.
It's easier to sort of mess up there or to be broad there.
Yeah.
Versus research, for example, right?
Yeah.
As we talked about. So why Copenhagen, and how did that happen? And let's talk about Pioneer Center as part of that as well.
Yeah, so it's impossible to separate that story from the pandemic, because I arrived at Cornell Tech in, say, 2013, and was very fortunate to have some good years in the city. Really fantastic.
Good time.
Yeah,
13 to 20.
The VC scene was exploding too, visual technologies. I worked a lot with LDV Capital, making these summits, just getting entrepreneurs and students together, brainstorming ideas. So it was just a really fantastic period. But New York City isn't, even under the best conditions, it's a difficult place. I mean, there's no shortage of people that want to go there, but it's hard to live there. It's a famously challenging place, and it really is a test for a lot of people. And I think I was vaguely aware of that, but it was just too exciting. And we had the first kid in 2015, second kid about a year and a half later. And but even then, before the pandemic, it's like, yeah, I can handle this. This is fine. And then the pandemic hits, and it was at the same time that I also started a stint as an associate dean. So associate deans, for those that don't know academia, it's the middle managers of universities. So they sit between the department heads and the deans. And above the deans, you got the provost, and then you have the president or the chancellor. Here it would be a rector. So the associate deans, they're still, you can think of them as, they haven't made the decision yet if they're going to go into the stratosphere of administration. And I don't know what the statistics are, but when you get to the associate dean level, you kind of have to make up your mind. Are you going to go back in the trenches? Like, are you worth more to the university alive? Like, you go back, start doing research, or do you get that taste of power and then you go up into becoming a dean or something like that? And so I don't think I even had that much time to contemplate that, and then the pandemic starts. So, and our dean left. He left for MIT. And the country was in upheaval from the Black Lives Matter protests, the Trump presidency. A lot of things were happening. It's like the country was just boiling. And I was in a position where I was not so close to my research anymore, sitting at a laptop in my attic, with Zoom. And Zoom wasn't so great back then. People were still on mute all the time, just trying to figure this out. And this, my wife was facing similar things. She's in the pharma industry. And our kids gradually they had to be at home for school. They were very little at the time. And I guess you could say that was a vulnerable state to be in. And I'd already been a visitor to Denmark quite a bit going back. I first met my wife in 2013, and then we started visiting Denmark. I got to know people at different universities that were doing AI-related stuff. I had already been on a number of thesis committees. I was an honorary professor at DTU, so I wasn't a stranger. But at some point during the pandemic, a few different faculty in Denmark said that a group of foundations, which are listed down here, they, together with the Danish National Research Foundation, wanted to create a really big national research center for AI. And the way they put it when they asked me was, would it be crazy to talk about this? Is that just talk with your family, see is this just crazy? In which case, we're still friends, you can still visit, but just see, talk to your wife, see what she thinks. Like I said, she'd thought about moving to Denmark, but that was now, 2 kids ago. Her career's thriving. But when the pandemic hit, it's like nothing made sense anymore. And so we thought it over, and one does not leave Cornell lightly. I mean, it was a fantastic place, and with Cornell Tech, it was even more exciting. And prior to the pandemic, I was going up to the main campus in Ithaca, which was my home department, once a month for 2 to 3 days at a time, bringing the kids. We had friends up there in a community, and it was a really fun, it was very busy, but it was just a really nice pattern that we had worked out. And the pandemic hit, and no one was traveling anywhere. And so I got back to my colleagues in Denmark. I said, it is not crazy, so let's talk about it. What does it mean? What would, and I knew at that point, whatever I was doing as an associate dean, that was not what I wanted. It was, at some point I might like that, but it was too early. And every professor has to confront that day at which point they should step aside or move into the administration. And I thought my day had not come yet. And so this was an opportunity to be a scientific director, not administrative, not a manager, so to speak, but and still get to be a professor, still teach. I just had lecture. That was what I was doing before I came here. And so I like those things. And so they described how the center would function. It was around 330 million Danish kroner. That's like over 50 million euro for 10 plus years. And I already knew that it was a very collaborative environment. And I think that there was something about the pandemic experience where I didn't care about rankings. Like, the universities in Europe just don't really, from an American perspective, it's just confusing. Maybe people know about Oxford, Cambridge, if you're lucky, maybe ETH Zurich. But there's not, of course, if you get into technical subfields, they know all about it. But I think that there was just something very appealing about what they were talking about. And so we during, you remember the pandemic got really bad and then it kind of subsided one summer before Omicron. Mm. And so my colleagues in Denmark invited us to spend 2 months in a summer. So I guess it would have been 2021. No, I'm not really sure. It's all a blur. Yeah. Because the lockdowns happened March 2020.
Yeah, so 21 then. Or that summer, later that summer maybe.
Yeah, I'm not sure. But we did 2 months, not vacation, just 2 months just trying it out. Put the kids in daycare, work. The time zone thing was a pain. But other than that, we were just trying to do our thing, but in Copenhagen. And I think maybe 2 weeks into that, we just said, wow, this is what we need to do. And that, it's kind of not fair to New York City because
it's very different.
New York, I don't think anywhere in the US was set up for a pandemic. Nowhere in the world was. But Denmark handled it a lot better than many other places and had a lot less strife in doing so. There was a relatively high level of trust in institutions that was completely alien to me because the US was in the throes of some of the worst division I'd ever seen in my life. And that was really demoralizing. And so I think that I was getting excited on a daily basis for these really small things. To most Danes, it would be stupid, like protected bike lanes, a metro that comes every few minutes, just clean subway car. I don't know, just like these things that I realized it's almost like I'd been living with trauma for a long time and just thinking, wow, it doesn't have to be so hard every day.
Yeah.
Like I didn't ride my bike, back in the New York City area because I didn't want to get killed.
Sure.
Yeah. So I guess in the end, it turned out to be an easy decision, and I've been here, coming up on a year and a half, and it's just been fantastic. I mean, I had one colleague, a former dean, who was pretty familiar with Denmark academia, had visited a lot himself, but he didn't want me to go, and he understood the family components and stuff. But the way he put it was, yeah, they've got good life-work balance there, but you're going to fall off the face of the earth, and that hurt.
Yeah.
I was like, oh.
And a year and a half in, have you, or what's going on?
I mean, I can't be the judge of that myself, but I think I don't think that's been the case.
No.
And I think, he may have said it to some extent to light a fire, but at the same time, I didn't build my career here. No. So I'm building new things here. Yeah. I had a career that was established elsewhere, but I happen to be based at University of Copenhagen, but the Pioneer Center involves universities across Denmark. It's Jutland, its capital region, altogether. But the quality of the students, the postdocs are fantastic. It's very international. So I feel like I haven't skipped a beat. And when I put out calls to recruit PhD students and postdocs, junior faculty, I'm not thinking to myself, oh, this isn't as good a place, or this is a disservice. No way. I mean, this is top notch.
Yeah.
So
we could probably go on for a lot longer, but I want to touch on sort of the plans of the Pioneer Center, and then narratives before we wrap.
Yeah, sure.
But yeah, so tell me the plans of the Pioneer Center. And I'm excited to be part of it in a small way, which is awesome.
Yeah.
So it's it's great.
Yeah, thanks. So for those that don't know, you're serving as a member of the National Advisory Board, which is really a critical component of the Pioneer Center. It also hints at the way that the Pioneer Center connects with the whole ecosystem, the tech and AI ecosystem in Denmark. The Pioneer Center for AI, it's the first of what will be 3 Pioneer Centers. So we call ourselves P1. We were the first one. The second one has to do with agriculture and technology. The third one hasn't been announced yet. So Pioneer Center for AI, it's basically 3 things. It's money, so there's funding to do research and set up labs. It's a vision, so it's a way of pursuing research problems that have deep tech and societal impact. And it's a place. It's a physical building, which is being renovated right now. So we'll be moving in there in a couple months. But it's these 3 things. It's money, it's a vision, and it's a place. And all of them are important. And I won't pick any of those as being the main thing. Place is important for people to gather, to have meetups, boot camps, code jams, et cetera. But we're also virtual. I mean, we have campuses, there's 5 campuses represented, but it's a place to gather. And that is directly analogous to what Cornell did with the campus in Manhattan. It was something that the people who were 3.5 hours away in Ithaca, they had a proper home in the city. And there's a similar atmosphere here. There can be a faculty member from Aalborg who has a distinguished international visitor that flies into Copenhagen before going to Aalborg, and they can set up meetings at the Pioneer Center, connect with other collaborators, and then take the train or a short flight to Aalborg. So it's a place. The vision, that's something I think we'd need some visuals to describe it, but it basically manifests in a matrix.
We'll link the website and some stuff so people can check it out. Yeah.
And so the way that you come into the picture with the National Advisory Board is that we have these 10 columns that represent areas of societal impact. There's 7 rows that represent sub-areas of AI, and those are our so-called collaboratories. Those are very academic. They're publication-focused, aiming for scientific output. Those are basically like computer vision group, natural language processing group. But the 10 areas of societal impact include things like biotech, health and life sciences, energy and infrastructure, ethics, bias, fairness, accessibility for the disabled. So these are different columns, and the students and postdocs that come into the center, they tend to think in terms of the rows. They want to write papers at CVPR and NeurIPS. They want to code. They don't want to go to meetings. I'm stereotyping here, but maybe they're afraid of applications because it's not hardcore. But we have systems in place to nudge their work a little bit into these columns. And then where the National Advisory Board comes in is this interface to Denmark, to Scandinavia. You can expand that radius to Europe, globally, but starting with Denmark, how do we connect, if someone's doing research that's relevant to MRI for hospitals, how do we connect those students in a way that they can maximize societal impact? So it's set up in a way that we cater to the interests of these top prospective students, postdocs, junior faculty. We know that they're thinking about writing papers, but we also find ways to nudge their work in a way that connects with these areas of societal impact.
I want to talk about narrative, but we've run out of time, I think. So let's leave it for a chat in the real building in February or something. We'll figure it out. But Serge, thank you so much for your time. It was awesome.
Great, thank you.
Thank you.